Okay, so before going to start, let me take attendance. Jesse is present, Mariam is present, and Shahid. You had period number 2? There is no attendance for period number 2. Okay guys, so yesterday we started electric field 5.1, so we will continue that lesson. Before going to start, just I will wait a minute. Okay, so yesterday we discussed about the charges. You remember or not? How charges can be produced? Can you tell? Who can tell? Jesse. Jesse, are you here?
Yes, sir. We can a little bit off by each other by motion.
What do you mean by motion? How?
So if we take the balloon and the sweater, if we rub it against each other, it will switch the charges.
Okay, so right now, can you tell this balloon is charged or not charged?
It is charged.
It is charged. How it is charged?
It's neutral.
It's neutral, not charged, yeah. How you can say it's neutral?
Because it's both negative and positive.
Yeah, means positive and negatives are equal. 4 positive and 4 negative, is it?
Yes.
And same thing you can see on the sweater, is it?
Yes.
Clear? So overall atom is neutral because number of positive and negative charges are equal. So how we can charge the object? Just by rubbing on each other. To remove electron, actually we want to remove the electron. When we will remove the electron, so that will be charged just like this. See, when I will rub this balloon you can see here. Now I rubbed here. Now look here, how many now charges on the balloon, negative charges, how many are there? Maryam? Yes, Maryam?
Very negative.
Sorry? Now,
Very negative.
no, I am asking that balloon is now, tell me, balloon is charged or not charged?
Yeah.
Which charge has balloon? Positive or negative? Negative. Why? Because it has more negative charges, is it? Yes, Shahad. Yes, Shahad. The wool has positive charge or negative charge?
The what, mister?
This wool has positive charge or negative charge? Sweater.
Positive.
How? How you know? How you know it's positive charge? Okay, wait, I will check again, 1 minute. See? I will show you again. Right now, it is neutral. Okay, neutral means number of charges are equal. Means, for example, here if there are 100 positives, so 100 negative. If there are 4 positives, so 4 negative. Both are neutral. Now I will rub this balloon here. Now see, electrons from the wool removed and stick with the balloon. So now balloon has negative charges because it has more negative charges. And now see, now this wool has positive charges because number of positive charges are now extra. Is this clear now?
Yeah.
So when I will release this one, you will see that it will go and stick with the wool. See, why it sticked here? Can you tell?
Because unlike charges attract.
Yes, good. Because unlike charges attract, and this is known as law of charge, that unlike charges attract each other and like charges repel each other. So you will see that I will show now. See, if I will bring it here near the wall, see, it repel the electrons. See, electrons are moving away. Now see, if I will rub more, this whole wool become positive. Okay, and now see, its force is more now. See, it will jump faster. See, it move. If I leave here, why? Because now at force of attraction is more, and you can see that here on the wall electrons are moving away because of repulsive force. Is this clear now? For everyone it is clear?
Yeah. Yeah.
Okay, let's go ahead now. Yesterday we discussed about the charges, how charge is produced. Now we go ahead. This we already discussed yesterday. Okay, so this is the charge law. As I told you, that you can see negative negative, they repel each other. and positive negative will attract each other. This is called charge law. Positive positive also repel. So remember this thing, according to law of conservation of charges, remember that if we remove 15 electrons from here, so 15 proton will produce. If we remove 10 electrons from the wool, so 10 proton will produce automatically. Just I will give you the example actually. I will explain with the Jamboard. Okay, for example, there is a balloon. Now it has a positive, negative. These are basically atoms. So there are, for example, 1, 2, 3, 4, 5, 6 atoms. 6 atoms means, see, this is one atom, second, third, 4, 5, 6. So all are equal because atom consists of positive and negative charges. As I told you before, that atom as a whole is neutral. Now if you are rubbing this balloon, okay, with any surface, for example you have a wool, you are rubbing it with a wool, so what will happen? So if you rub with the wool on this side, this is a wool, okay, so when you rub, electron will jump and stick here. So when electron will go there, this electron will also jump and go there, this electron will also jump and go there. Now see, there is no electron here, there is no electron, there is no electron. Now look here, number of proton here, 1, 2, 3, 4, 5, 6 protons, and 1, 2, 3 electrons are there. So it means protons are more, so it means charge on this is +3. And charge on the wool is, how many electrons went there? 1, 2, 3. So -3. So this is the thing that, as I told you, according to law of conservation of charge, that electron, how much electron you are removing, so same electron, so you remove 3 electron, so 3 proton produced positive charges. Is this clear now, all of you? Guys?
Yes.
Okay. So now see, a cat's fur like your hair, okay, acts just like a wool. When you rub a balloon on it, a balloon has picked up -150 microcoulomb of charge from Albert. Albert is the name of the cat. When you rub the balloon with the fur of the Albert, a cat, the balloon picked 150 microcoulomb charge, that is negative mean electron. So electron will go to the balloon. So overall how much? 150 microcoulomb overall charge on the balloon. Question is, how many electrons have been transferred? And second question is, what is charge on the Albert? Yes. Can you do? Or should I explain?
Sir, can you explain?
Okay. Now see, first of all, how many electrons have been transferred? So you have to find out the electrons. So I will again go back to the Jamboard. say the cat electron transfer from cat to balloon, how much? Minus 150 microcoulomb. This is total charge. Okay, this is Q, capital Q. We represent charge by Q. It can be minus small q or capital, okay, no problem, anyone you can write. Okay, so minus 150 micro, this symbol show micro. Micro means 10 power minus 6. You can write minus 150 times 10 power minus 6 coulomb. Okay, now they're asking how many electrons transfer. Just I will give you example, then I will solve this question. See, for example, this is any substance. Just like suppose balloon is there. Its total charge are 10. Means 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So number of electrons are 10. Clear? So charge on one electron is how much? Yesterday I told you to write down your notebook. Can you tell? Charge on one electron. Don't know?
1.60 times 10 to the power of negative 19.
Yes, 1.6 into 10 power minus 19 coulomb. So see, on one electron charge is 1.6 times 10 power minus 19. So if there are 10 electrons, so what will be total charge on this balloon? How you will do? It's very simple. Total charges are 10. Total electrons are 10. Charge on one electron is 1.6 10 power minus 19. So what is total charge on the balloon? Simple mathematics. Shahid.
Do I just multiply, right?
Yes, exactly. Just multiply. See, 10 total electron, okay, and charge on one electron is 1.6. So you write 10 times 1.6 into 10 power minus 19. This is total charge. So simple, you will multiply number of electrons with charge on one electron. So we can make a formula now. Total charge is equal to number of electrons represented by small n and charge on electron. Q is equal to Ne. N is number of electron and E is charge on electron. And capital Q is total charge. Did you get this?
Yeah.
Okay, so write down this portion in your notebook, then I will go ahead. This portion only. Q equals to Ne, and this N represent, E represent, Q represent this portion. Okay, this is important. Done?
Yes, I'm done.
What about others?
Done, sir.
Okay, now come toward the question now. See, this is the formula. Q equals to Ne. Now, in the question they are asking how many electrons transferred to the balloon. So, means they are asking N, number of electrons. So, N is equal to Q by E. Rearrange. Now, Q is given in the question, that is 150 microcoulomb. So, you can write 150 micro means 10 power minus 6 coulomb. So, you will write here N is equal to 150 times 10 power minus 6 divided by E. E is 1.6 into 10 power minus 19. So, this is unit is coulomb and coulomb. So, coulomb with cancel. So, there is no unit for N, okay. So, just do it now. How much? You can use in this way 150 divided by 1.6 times 10 power minus 6 plus 19. It become 13. So 150 divided by 1.6 how much? Can you tell? 150 divided by 1.6?
93.75.
92.75?
93.75.
Okay, times 10 power 13. These are the number of electrons. Is this clear for everyone?
Yeah.
Okay, write down in the notebook. This is answer of part A. Question you can write from there.
Mr. Done.
Okay. Yes, others, have you finished?
Yeah, done.
Okay. So, see now, actually, in the question it is written that minus 150 coulomb goes to the balloon. So, part B is what is charge on Albert? So, charge on Albert is of course same as I told you that For example, in balloon it is minus 150. Okay, for balloon. So same, this will be plus 150 will be in the Albert. As I told you before, number of charges transfer, so it will be equal according to conservation of charge. So if it is minus 150 charge on balloon, so plus 150 will be on Albert. You got it? This is answer for the part B. Plus 150 microcoulomb charge appear in the Albert. Clear?
Yeah, clear.
Okay. Here is the answer now. So I think your answer was 94, they wrote 9.4 and then they added it here 14. So it's okay, both answers are correct. Okay, now the terminologies you should know about the conductor, insulator and semiconductors. Do you know what is conductor? Any one of you can tell in your own words? Anyone? Yes, Maria. Can you tell conductors? If you cannot define, just give me the example of conductor. Do you know what are the conductors?
Materials that allow electric current to pass through it.
Yes, good. Example?
Aluminium or any metal.
Yeah, good. Aluminium or any metal. So metals are good conductors. So conductors are the any materials that allow charges to pass through. Okay, these are called conductors. So second thing is insulator. Yes, Jesse, what is insulator?
It's the one that doesn't allow electricity to pass through.
Yeah, good. Example?
Coating on wires.
Sorry?
The coating on the wires.
Yeah, but coating, actually you should mention the material. Coating is a material. What is that material?
Plastic.
Yes, plastic. Yeah, plastic, rubber, wood. These are the insulators. Okay, Shahad, what is semiconductor?
The materials that have a conductivity between conductors, like they're in between.
Yes, in between actually means what? In between means actually they are insulators at room temperature, but when temperature increases they become conductors. Okay, so that's why it is called semiconductors. Normally at room temperature they are insulators, but as soon as temperature increases they become conductors. The example is silicon, germanium, etc. Okay, these are the semiconductors. So I will show you the periodic table. This is the periodic table. In the periodic table you can see that there are colors in the periodic table. Are you studying chemistry? Is it, all of you?
Yeah.
Okay, so then you will be familiar with this one, that there are colors on the periodic table. So this you can see there are three colors. So colors shows actually this conductors, insulators and semiconductor. How? These are the metals. So you can see this metal, all these are the metals, means conductors. Okay, and then non-metals, this color is for the non-metals. Okay, that is insulators. Okay, and then metalloids, that are the semiconductors. So green color is this one here. This is metalloid or semiconductor. Clear?
Yeah, clear.
So from the periodic table colors, from the colors you can just, if you have a periodic table, then you can tell that this element is metal or non-metal. From the periodic table you can tell. Okay. Next is electroscope. Let me check how many minutes left, because it's little bit more. This period number 3, is it? Okay, so time is almost finished, so we will continue this tomorrow, okay? Because it's a little bit more. So tomorrow we will continue about the detection of the charges, that how we can detect charges, okay?
Okay.
Up to this, any doubt, any question?
No, everything's clear.
Then okay, thank you very much. So see you inshallah tomorrow. Okay, bye bye.